Now we will move on to uh, the rise, assert, and with as statements. This is part 3 of module 7 exception handling. So we will begin with the rise statement. To trigger exceptions explicitly, you can code rise statements. Their general form is simple. A rise keyword, a rise statement consists of the word rise, optionally followed by the class to be raised or an instance of it. You can find a piece of code below the block. So arise, optionally you can use a class, make an arise instance of class, or rise re-rise the stuff. Like you don't need to anything, you don't need to add anything after that. Re-rise the most recent exception. These are the different ways we can use the rise statement. So as mentioned earlier, exceptions are always instances of classes. Hence, the first arise from here is the most common. We provide an instance directly, either created before the rise or within the rise statement itself. If we pass a class instead, Python calls the class within no constructor arguments to create an instance to be raised. So this form is equivalent to adding parenthesis after the class reference. The last form re-raises the most recently raised exception. It's commonly used in exception handlers to propagate exceptions that have been caught. So next, the assert statement. As somewhat special for debugging purposes, Python includes the assert statement. It is mostly just syntactic shorthand for a common rise uses pattern, and an assert can be thought of as a conditional rise statement, a statement of the form. So you can see a statement of the form below. You will have a assert and then a test. The test is very important in assert statement, and then data. So rise instance of class. Uh, it works like the following code. So if you look into that before looking to the complete code, I would also like to tell you one more point. In a if the test evaluates, so in assert, so the first statement is assert space test and then data. In that, if the test evaluates to false, Python raises an exception. The data item is used as the exceptions constructor argument. Like all exceptions, the assertion error exception will kill your program if it is not caught with a try, in which case the data items show up as part of the error message. As an added feature, asset statements may be removed from a compiled program's bytecode if the Python command line flag is used, thereby optimizing the program. Assertion error is a built-in exception, and now you can see that railing double underscore debug leading double underscore flag is a built-in name, and that is automatically set to true unless the O flag is used. Use a command line like Python O main.py to run the optimized mode and disable assets. So before moving to the with as one more point to be discussed is assertions are typically used. The main application of assertions or assert statement is they're used to verify program conditions during development. When displayed, their error message text automatically includes source code line information and the value listed in the assert statement. We will create the file asserter.py and test it later in this session once we done with the uh, theoretical aspect of with as statement. So now with as a context managers, this with as statement, the with and its optional as clause. This statement is designed to work with context manager objects, which support a new method based protocol. The with for rows class as statement is designed to be an alternative to a common try or finally uses EGM. Unlike try finally, though the with statement supports a richer object-based protocol for specifying both entry and exit actions around a block of code. So you can see the typical uh, with as statement. So with and then expression as variable, and then under the header you will have a with block. So now the basic format of with statement just we have seen. Now the expression here is assumed to return an object that supports the context management protocol. This object may also return a value that will be assigned to the name variable if the optional as clause is present. If the optional as clause is present, so note that the variable is not necessarily assigned the result of the expression. The result of the expression is the object that supports the context protocol, and the variable uh, maybe assigned something else intended to be used inside the statement. The object that returned by the expression may then run startup code before the with block is started, as well as termination. This is important, as well as a termination code after the block is done, regardless of whether the block raised an exception or not. Regardless, that's important, regardless of whether the block raised an exception or not, the termination code after the block is done. So now we'll just directly uh, jump into the Jupyter notebook and see. Okay, we'll begin with rise. So basically rise with built-in exceptions. The following are two forms are equivalent. Both rise, either we can look into rise an instance of the exception class named, but first creates the instance implicitly. Okay, what we'll do is rise keyword and then index error. This is a class. Index error is a class. We are directly calling it. So when we call index error directly, implicitly instance will be created. So that's what happened here. Index error and then index error instance is created implicitly. So then in the second case, we'll mention it. We will explicitly create an index error class instance. Here index error and we are calling it, so we are able to create explicitly. Let's just see. So rise index error, we are getting the same kind of error, but one is implicit and another one is explicit. So now we can also create the instance ahead of time that we have to assign it to a variable. So because the rise statement accepts any kind of object reference, the following two examples rise index error just like the prior two. So here index error, this is instantiating our index error class and I am attaching that object to the exception name. So now I'll raise the exception. So basically this is an implicit way of doing using a variable. So the outcome remains same. So now there is one more way to do the exceptions, and you can take a list of errors, list of exceptions inside that, and you can raise the exceptions variable name, and we'll get the same thing. So type error we got this time. So basically this depends upon hierarchy that we will discuss later in this session, in this part of module. So based on that hierarchy, uh, whichever has the higher hierarchy will be executed. So here the type error got executed irrespective of the position. The type error will only be executed. So then when an exception is raised, Python sends the raised instance along with the exception. If a try includes an exception name as x clause, the variable x will be assigned the instance provided in the raise. Let's see that here. So try, and I have wrapped this array and then index of that string inside the try statement and accept. So basically my class is index error as x. When I say as x, basically x is I'm just instantiating the index error class, and then I'm storing it in x. So x, it will be x assigned the raised instance object. So basically x is an object now. So now print index error is triggered. So obviously this is a other way to do using an as clause. So including it allows the handler to access both data in the instance and methods in the exception class. So next we will see propagating exceptions with rise. So what we'll do here, this form is typically used if you need to catch and handle an exception but don't want the exception to die in your code. In that case, we will propagate it. We will use this method. For that, what we'll do is you raise it an error basically, and then when you put it inside, when you wrap it inside your try in your try statement, then basically you're catching it, and then use except to handle it, but still you don't want to you don't want the exception to die in your code. In that case, you raise it again. You raise it again. Basically, it's a re-raise. That means you are not that we have discussed in theoretical session of this part. So you can revisit that. But so basically, it's a re-raise, the most recent exception. Just use rise. You don't need to mention anything, any class, any exception class, or any exception class object in, for following the rise. So next we'll be looking into assert statement. So here assert is basically to wrap constraints, not but not errors. So what we'll do is, as we had discussed earlier, we will create an asserter file, and then I'll open a Jupyter notebook here so that I can create an asserter file here. So yes, this is the file I have created. So name of the file is asserter.py, and then inside that I have created a function f, and the name of the function is f, and of x is our parameter, and then assert is a statement, and x less than 0 is our test condition, and then this is our value, our data. You just say data x must be negative. So and then return x per 2. If x less than 0 is false, then only it throws an error. If is true, then it won't. So let me save it, and I'll import it through Jupyter Notebook and will do. So that module got imported, and then I'll just try to access the namespace of the module, that is asserter. Let me execute it. So yeah, we got the namespace. It consists of F, that's the function name, rest all are built-ins. So as this is exceptions, the built-ins trailing double underscore built-ins trailing leading double underscore method has also been included in your module, because this is about exceptions. And then use asserter.f of 1. Basically our test condition for asserter is x should be less than 0, but this is false, it will throw an error. So as it is a false, it will throw an error, and the error name is assertion error, and the message or the data that we are sending or showing it to the user is x must be negative. That's what we have mentioned there. So we will take another example that also by and large does the same task. So now the with or as context managers, the fourth one. So for example, we'll check a file object. So file objects have a context manager that automatically closes the file after the with block, regardless of whether an exception is raised or not. So basically this with and as is very helpful for that. Basically my file, that's our file handler, and open is inbuilt function, and file with .txt, that's what the name of the file. I will add one, and then open it in W, that's a processing mode of writing, and then add Krishna Hare to that file. So let me execute it. Total we have 11 characters got written inside our file, and now what we'll do is we'll use with as context manager to automatically close the file without explicitly using close method of the file handler. So with open file 1.txt, let me open, and then and then as my file, my file is the name given to, or my file is the file handler to that. Now for line in my file, that's a for loop we are using it to access or step into the strings inside the file and print, and then print this. So here see the file has been closed. That's what you can get it from here. So then after that, using explicit try finally statement to close the file, this is a different way. So that's what I was telling you before, that we can use close method to explicitly close the file. And this is another example. This is a bit advanced, but I just want to show you this. So let's look at a quick demo of the protocol in action. The following defines a context manager object that traces the entry and exit of the with block in any statement it's used for. So basically here we have created a class, and we have added a constructor to the exception customized class. This is our own class. To raise block, this is our own class, and then we have added a constructor to it, and then we have added the methods to it, and then inside exit method we also had a if else statement. So if you are confused about this class statements, and then what I'm talking about, you just visit my module 6, that is on classes and oops. I have explained it very intuitively, because I have used real world examples. So kindly look into those videos, and then you can again come back here and watch these videos. So so here we have created our own exception, that's a trace block, and then using this with as protocol with as using with as context manager protocol, we are able to create a trace block kind of methods. So with this, we come to an end of part 3 of module 7, and I would like to thank you for watching my video, and keep and spreading it to your friends, and I would also request you to keep subscribing it and keep liking it, and keep sharing it to your friends and family so that everybody can get benefit out of it. With that, I would like to say thank you, and see you again in another session.